Today I'm going to explain my fourth experiment in data science ecosystem. The first question to calculate the sample mean of unit price using a random sample of n equal 15 observations for each branch and repeat the sample and compare the sample means. Here for this I have installed an empty dictionary to store sample means for each branch where sample means equal to q1 for a branch in the df of cleaned branch dot unique which iterates through each unique branches name present in the dataset and filters df.clean to keep only rows corresponding to the current branch and checks if the branch contains at least 15 rows required for sampling. Then randomly selected 15 values from unit price using seed 42 for reproducibility, and which mean one dot equal to sample one dot mean which calculates the average of first sample, then sample two which selects a second random 15 values using uh, seed 100. And then I have printed the message explaining the sampling could not be performed if the value is not enough. Then second question is to calculate the sample mean of unit price using a random sample of n equal to 25 observation and compare it with the sample mean obtained for n equal to 15. So we have installed an empty dictionary to store sample mean of n equal to 25 and for branch in df.clean the branch dot unique which loops through each branches. Then branch data which is a variable which the df cleaned of df which selects the cleaned branch which filters data for the current branch and the cleaned branch. And I used if functions to check if branch has at least 25 records, and I have printed the sample mean of unit price where n equal to 25 which outputs calculated sample mean of n equal to 15 and else statement which execute if no n equal to 15 sample means are available. Then the third question is to calculate the population mean of unit price for each branch. Here, group by function is used. Group df cleaned by branches and computes the average unit price for each entire branch acting as a which act as a population mean here. And I have printed the if prints a descriptive label that population mean of unit price for each branch and displays the resulting population means in series. And fourth question is to calculate the 95% confidence interval for the mean unit price using sample of n equal to 25 observation and observe the whether the population mean lies within the confidence interval or not. So in this, first I have imported the NumPy for scientific calculation and CPy for to work with statistical distribution, and I have in- and I have used the confidence level variable which is equal to 0.95, sets the target level as 95%, and for branch in df of cleaned branch dot unique which loops through each branch and branch data of equal to df cleaned branch if equals to branch which it filters the data for given branches and n equal to len of branch data which counts the total number of available observations for each branch. And I have printed branch name and in displays and inform in the displays the note whether the defaulting full sample size n. If n is greater than 1, it checks whether enough data points estimated standard deviation and s equal to branch of data of unit page dot stat which calculates a sample standard deviation. And I have printed the error message for small samples. And fifth question is to change the confidence levels of 99% and calculate the confidence interval for the same sample. Compare the 95% and 99% confidence interval. First, I have introduced the confidence level as 0.99% and iterates through each branch and filters branch data and gets number of observations and prints the branch label and ensures sufficient data points if using if statements. If exists, it enter equal to enters into the if statement and calculates the sample mean and calculates the sample standard deviation and calculates the standard error and sets degree of freedom. And if it's not comes under if statement, it moves to else statement and prints not enough prints is which triggers a n is lesser than or equal to 1 and prints the low data invoice. It notice. And sixth question to select the 25 random samples, each containing n equal to 15 observation and calculate the 95% confidence interval for unit price for each sample and plot the 25 confidence intervals and observe how many intervals contain this same population mean. So here for this question I have imported matplot, pyplot module for graphing and imported cbon library for enhanced visual styling and I have declared sample count equal to 25, which sets total number of repetitive samples equal to 25 and sample sizes set sample size for each style 15 and confidence level equal to 95% and loops through unique branches and moves through the filter branch and checks size of the branch and prints the branch header. And here, if it comes under if statement, it prints us code. It prints us the skip message and skip further code execution for current loop iteration. And then second for loop is for runs a loop 25 times to generate 25 samples and it moves through for loop and condition satisfies and prints the confidence levels confidence interval which containing the population mean out of and the proportion of each mean each branch. Here's the given uh, given population for branch A and branch B. Then seventh question is to consider the variables quantity and price. Unit price, calculate the Pearson correlation coefficient for each branch and interpret the relationship between the two variables. In this question, I have used a for loop which loops to each branch and same as before question. Checks for minimum number of data points needed for correlation. If length of branch of data is lesser than of 2 and prints if display missing data warning and here's continuous statement if the condition follows satisfies it skips the iteration and moves through another loop elif statement and moves through elif statement uh, b- depending upon the condition it satisfies and prints the negative correlation prints the correlation of each effect. Then eighth question to consider the variables rating and unit prices, calculate the Spearman correlation coefficient for each branch and compare the results with the Pearson correlations coefficient. For this question, in this question, first loops through each branch and I have calculated the Spearman rank correlation coefficient between rating and unit price and print the output Spearman correlation value rounded to two decimal places and calculates the standing Pearson linear correlation coefficient between rating and unit price and I have printed the output for pair relation correlation value rounded to two decimal places and you use the if conditions. Six, if the magnitude of Spearman correlation is greater than Pearson and in comparison I have stored the interpretation for stronger Pearson association and use the LE function. Six, if magnitude of the Pearson correlation is greater than Spearman and finally I have prints the resulting correlation comparison statement among them. Then ninth question to calculate the covariance matrix for The numerical variables were unit prices and for each given attributes for each branch and identify the variables having the strongest positive covariance. Here, I have stored the given attributes in the numerical where's a variable, and I have iterated through for loop. And if enough branch of is satisfies, it prints the what are the enough data in the branch to calculate and skips. And in Go matrix variable, I have stored the branch numerical data and uh, displays the covariance matrix. And here then max equal to in this variable I have stored information of np info of np and used for loop to calculate the checks if the current pair's covariance is greater than the highest covariance found so far and updates with the new maximum values and updates strongest pair with the current tuples of variable names and print checks if a valid pair with a positive covariance was found and prints the variable names and their maximum covariance value rounded to decimal values and uh, depending upon this statement it follows and uh, prints the output. Then 10th question is to perform a hypothesis test using the z test. Here I have imports the NumPy library for mathematical operation and a CP module for to work with standard normal distributions and define population mean equal to 50, which defines the claimed population under the null hypothesis and sets the unknown population standard deviation equal to 12 and sets the size of the random samples equal to 25 and sets the significance level equal to 0.05, which and prints the formal statement for null hypothesis and prints the alternative hypothesis using print statement and using standard deviation formula I have calculated the and z test statistical formula I have calculated the z test and prints the calculated standard error rounded to decimal places where the 2 and for result statistical prints the computer result statistical value which rounded to 2 decimal places and prints the for in the print of in the at last I have printed the calculated p-value rounded which decimal places are rounded to 4. Thank you.